Well, good afternoon. My name is Vadim Gerasimov. I'm a part of the Wave API team, and today I'm going to talk about the Google Wave APIs. Google Wave is fun, but you can make it even better by adding your own extensions and writing your own applications in Google Wave. So, what can you do? First of all, you can add Wave to any web page, anywhere on the web. For that, we have Embedding API. But besides that, you can write your own small applications that can either extend the user interface elements within the Wave, or you can write your own automatic participants that we call robots. Besides that, you can write special installers that help users to put the robots and gadgets that you wrote inside the Wave. After that, I'm going to briefly talk about federation. People can write their own Wave servers that will talk to the Wave infrastructure. We have a standard federation protocol for that. And I'll finish with a roadmap, what we're planning to do in the future. First of all, where is it? So to access Wave, you can go to the Wave sandbox. That's a special server for the developers. You can also go to the Wave preview. You can take a look at the API documentation. This site includes a lot of examples and sample gallery. You can look at what kind of code you can write, and you can install some of those extensions in the Wave and see how they work. And you can stay up to date on our blog. Let's start with embedding. So how to embed? One way to embed is to add gadgets to the web pages. So you can add gadgets to any open social containers. One example is iGoogle. So for example, here you see Wave embedded in iGoogle. And well, you have other gadgets here. You can feed a hamster too. And this Wave is live. So if you take a look at the same Wave, in the regular client, you will see you can update the gadgets. And you can see that it is live. So the other way to embed a Wave is just adding a simple JavaScript to any page. This is kinds of objects that the JavaScript deals with. First of all, you have a Wave panel. And in the Wave panel, you can either load a search, you can add a search expression, and then you will see the list of waves as you see in the search panel in the Wave client. You can load a particular wave by the wave ID. And you can change the user interface configuration as well. So in user interface configuration, you can change colors, you can select fonts. You basically can customize the Wave for your page. So if you have a different background or other parts of the page use different styles, you can fit the Wave to your purpose. So, and this is an example of embedding. This is the script that just loads the embedding script, initializes the Wave panel, sets user interface configuration, and initializes the Wave. So it looks like this. That's the embedded wave. As you can see, the color is red here. So if we go to the wave, this wave is also live, so if you okay, I'm not sure where Lars is. So let's oops. Oops, excuse me for a second. Here's my presentation. So, let's talk about extensions. You can add extensions. By extensions, we mean robots, gadgets, and special XML scripts that describe how to install them. So usually robots go into the list of participants, and we usually use special robot pictures for them to show them. Extensions, one way to add extensions is to put them in the among the buttons in the toolbar. So when you click on this button, the extension installer automatically performs actions that are necessary to install the extension. And gadgets are just part of the API, part of the user interface, so they appear within the wave. So what are the difference between robots and gadgets? Robot, again, is a wave participant. It runs in the cloud. It runs on a separate server, and it interacts with the wave using the wave server. So it pretty much works as as a separate participant. So it can do almost anything a human being can do using a client. And in fact, it can sometimes do more because it can see the internal structures of the wave. The robots have a complete view of the wave, so they see all the text. They can change bleeps, and they can modify any part of the wave. Gadgets are wave elements. They run on the client. The gadget can interact with the user directly, but the only part of the wave it can change is the part that belongs to this gadget. The gadget, for security purposes, cannot see anything outside of its scope. If you want an extension that combines interactive user elements, gadgets, but you need features that require access to the wave, you can write a combination of a robot that will provide the gadget with necessary information. So gadgets. Anything that works on the web, you can put inside the wave, and that's what gadgets are for. Wave gadgets can get several wave features for free. First of all, when you write an application inside the wave, it has real-time state synchronization across all clients. So this application can interact with multiple users, and the wave infrastructure will automatically synchronize the clients. All you have to do is to update the state, and all the clients will receive the same state through the wave. You can get playback, which helps you to see what what was happening with the gadget over the time, and you get real-time interaction with multiple people and robots. Hosting gadgets is easy, so you can either use Google Gadgets editor. It's very good for really simple gadgets where you have just one XML file that includes all the necessary information and scripts to run your gadget. If it's more complicated and requires multiple files, you can host it on the App Engine. Well, when you write robots, you will use App Engine anyway, but you can also put bits and pieces for the gadgets in the same place. And Gadget XML can live, in fact, on any website. So to add gadgets to the Wave, you can use the toolbar menu, the green gadget button. You can use robots that can automatically insert the gadgets. And in the sandbox, as a developer, you can use the debug menu to add gadgets. In the Wave Gadget API, what Gadget knows about the Wave? First of all, it knows the host. By host, we mean the person or participant who added the gadget. It knows all the participants with their addresses and real names and pictures. And the gadget uses its own state to store information. The state is synchronized across all the clients. And besides that, it has mode. Mode is the state of the editor in the current wave. So for example, if the participant just opened a wave, looking at it but not editing it, it will be in a view mode. If the participant click on edit, the gadget will receive the update that mode is edit. And in the playback, it will have the mode playback. So the point of this is to alter behavior of the gadget depending on what's happening or in what form the participant sees it. The gadget can register for 3 types of events. It can register to receive participant updates. It can register to receive state, and it can register to receive changes in the mode. And the only thing that Gadget can change in the Wave is its own state. Another interesting point that Wave supports not only Wave gadgets specifically written for the Wave, but you can try to add any gadgets that work in iGoogle or other open social containers to the Wave. They will not be wavy, but they will work. This is a code example of the gadget. Gadget includes some boilerplate XML that basically declares what features this gadget would use. For Wave Gadget, we recommend to use locked domain to make it secure. We recommend dynamic height. Gadget can automatically adjust how much vertical space it takes in the wave. And the main feature to make Gadget wave aware is wave. You can include any HTML here, so it may include some JavaScript. It may include Flash and anything you want. This is the most basic gadget that registers for the state update, and it has a couple of buttons. One to update state, and update state just increments a counter and saves it in one of the states, key value pairs. And reset state just sets the counter to 0. So I'll show you how this gadget works. So I need to select simple gadget. This is a pointer to the XML of the gadget. You can take a look at that. That's the XML of the gadget, and I can add it to this wave. In the edit mode, you click on Add Gadget by URL, insert the URL, and the gadget appears here. So again, it's live. All you need to do to synchronize it is just to set the state and receive the state. Sorry, I need to maximize this. So if I increment the counter, I can see that it counts, and it will count in all the clients. I can reset it as well. Automatic height adjustment is important because otherwise, since we don't have scroll bars, forcefully disable scroll bars, it may not fit in the window. So it's important to use the dynamic height. It's also recommended to tightly couple rendering and state updates. What it means is, rather than well, for example, if the user presses a button and this event should be reflected somewhere in the user interface, do not do this immediately. First, just tell the wave that the state is updated, and tell the wave what the new state is, and wait until wave sends you the state back. And if you do this way, the gadget will automatically work with the playback, and it will work in any strange situation where synchronization is not straightforward. And in general, develop with the playback in mind. So after you develop the gadget, try and see what's happening in the playback. So, and gadgets are good for writing all sorts of user elements within the wave. They are good for writing rather sophisticated small applications like games, and it's good for writing collaborative tools. Robots. So the general architecture is such that the robots that you can write using our robot API reside in the app engine. So you basically write a web application, and the web application, rather than talking directly to the person, to a user, it talks as a participant to the robot proxy in the wave. And the robot proxy just channels the requests from the robots, and from the robots to the wave, and from the wave to the robot, and controls the flow of the robot actions. So, and on the other end is the client where the gadgets live and where the participant interact with the wave. We also have a couple of internal agents or robots that are not connected through the robot proxy, but work with the wave directly. One example is Spelly, the spell checker. It's fairly smart, and well, it has a few extra user elements that are not available to ordinary robots, and that's why they are not linked through the robot proxy yet. So Robot, again, lives in the cloud, external robotic participant, and it has full access to the wave, respond to events on the wave. Currently, you can write robots either in Java or Python. Both APIs are available, and they're fairly sophisticated comparing to the Gadget API. Gadget APIs are kind of minimalistic, and robot APIs are rather complicated because they require complex event processing in the wave. So this is a simple smiley robot that modifies the wave. It looks for emoticon smiley in the wave and replaces it with, replaces it with the Unicode character that corresponds to this smiley. So I'll demo a couple of robots. One is called Emoticoni, and the other two are called Monty and Syntaxy. So let's add Emoticoni here. And it can recognize quite a few emoticons. So what happens here is the update to the blips, to the wave, are sent to App Engine. The application in the App Engine Emoticoni detects, looks for particular patterns, and if it finds this pattern, it replaces it with the images. Another example is Monty. Monty is a robot that knows Python. So I can write something in Python. Yeah, let's just generate powers of 2. If I click done, it calculates it, processes it in Python. And the other thing robots can do is Syntaxy highlights the syntax of, it's a syntax highlighter for a language. Oops, that's not supposed to happen. So I'll reload the wave. And add syntax again. And syntax asks me to specify the language. So it's Python. Okay, and you can see the highlight, so it changes color depending on on the type of the language element. So, and robots can process waves, and there are plenty of applications for them. So, besides working specifically in the wave, they can connect to other servers. So, for example, it can assist in a search and do search on the app engine and return results in the wave. So we can have all sorts of interesting robots like email integration, publishing robots, calculators, etc. Extension installers. So adding robots by the name or gadgets by XML is kind of inconvenient. So for the end users, it would be nice to have something that they can just click and add all the necessary elements in the wave. The trick is that in some cases the extensions require more than just a single element, and that's where extension installers are especially useful. So it basically bundles it describes in XML all the elements that should be added, and it also describes the events that that should be used to enable those extensions. So there are hooks. So the extension installer can act when you click on a new wave. The most common now used extension installers connect to the toolbar menu, so those small buttons in the toolbar. They can also connect to keyboard shortcuts and macros. And currently we're also working on regular expression hooking. So if the system sees a particular regular expression pattern in the wave, it can also enable an extension. So, and hooks basically enable extension installer to do something, and actions can include insert a gadget, add a participant, and participant can be either a person or a robot. It can create a new wave, and it can apply annotations. So annotations examples are colored text, for example. So, and the interesting part that the extension installer can just do highlights without doing anything else. So an example of extension installer for inserting yes, no, maybe gadget from the toolbar. So it basically describes the name. URLs are omitted here, and well, it basically describes, it's a complete description of where the installer should go and what it should do when the user wants to add this extension. So let's see an example of extension installer. This is the yes, no, maybe gadget installer. The extension installer can be added to any wave. It's currently done through the debug menu. And you just specify the XML. So, as you can see, it has the description that was specified in the XML, and it has a button that is used to either install or uninstall this extension. So if I click on install, I can see that this button appeared here, insert yes, no, maybe gadget. If I click it again, it disappears. So after I install the extension, I can immediately use it. So that's yes, no, maybe gadget. So with extension installers, you can publish your extension manifest publicly, and people basically can immediately start using your extensions. Currently, the way to add extensions is not very straightforward, so you need to use a debug menu, add extension, and paste your URL. And after that, you'll be able to install and uninstall extension. But people can also share extensions by just adding other participants to the waves that include installers. So let's talk about federation. Google Wave is a product, and Wave is a technology. So in a sense, Wave is to Google Wave is what email is to Gmail. Wave federation makes it possible for independent wave providers to interoperate, to develop their own independent wave servers. Draft federation protocol is published, and it's not final, it's a work in progress, and you can monitor the progress of this protocol on the web. Why are we doing? Why are we working on the Wave Federation? It's first of all, it's to encourage adoption of the Wave as technology and ensure that users have a choice of Wave providers. So the internet was built as on open APIs and standard protocols, and Wave continues this trend. We don't want the Wave to be a siloed communication tool, proprietary communication tool. And we would like the users to pick a solution based on price, features, or other properties of the products. We would like to avoid avoid different organizations building wave servers that cannot interoperate. So what's a Wave data model that allows a federation to work well? Wave itself is just a container of wavelets, and wavelets is a unit that can be federated. The wavelet includes participants, and it includes the document that's a unit of concurrency, and it can be a unit of Wave federation as well. Wave servers run operational transforms and concurrency control, and they should be compatible. They should use the same type of concurrency control and operational transform to be interoperable. Wave servers can share updates and wavelets, but only one single server owns a particular wavelet. And to specify which one does, the ID of each wavelet includes the domain that specifies where the wavelet where the wavelet belongs, and where other Wave servers should go to fetch this wavelet. And the second part of ID is just a unique name. How Wave servers know when to federate, where to send information from one server to the other is basically by addresses. The wavelets have a domain, and when participants are added, the domain name also specifies where the wavelets for this particular user may be. A participant domain determines where to send the ops for this particular user. So I'll show you a brief example of how two Wave servers can interoperate. And I can do that because the Wave sandbox now has open federation port that can be used to develop other Wave servers. So I'll just jump straight here. This is Acme Wave server and Wave client. The Wave client has an interesting design. So what I can do is create a new wave. Very nice. So I'd like to open, I can see my inbox. It's consists of three waves now. So I want to open wave number 2. And actually, this is me at Acme Wave. So I added this text to the wave, and now I want to share it with myself, but on a different server. So I'll go to my inbox here to see when this wave appears in my inbox. And I need to add myself here. So I do add Vadim at wavesandbox.com. So on this wave resides on acme.com wave server. It should be now shared with me on this server. Oh, here it is. And now I can respond to it from this client. Well, and I don't see the whole message, but well, part of it got there anyway. So that's how a federation works. So, and wave federation architecture is fairly simple. So there are different wave servers. Clients can connect to those wave servers, and there are pairs of federation hosts and federation remote systems that talk to each other using XMPP, well documented in the Wave Federation protocol. So the advantage of federation is that if you're concerned with privacy, all the waves all the waves and wavelets that belong to people within a single organization will stay inside this server. They will never cross the boundary to any other wave server. What we've done so far with federation, we published the draft protocol specs for Google Wave Federation protocol. We have a Google Wave conversation model, including a bleep model, which is important for concurrency control. We open sourced about 42K lines of code, effectively, it consists of two components: wave model from operational transformation and basic prototype of the client server that you can use as a reference implementation. And we recently opened up a federation port on the Wave Sandbox. It's highly experimental, but it kind of works, as you could see. Updated the Fed1 client server. A client now does a better job of displaying operational transform. The server understands the new protocol manifests. We also published the licensing agreement. So you can monitor the progress of the Wave Federation on the blog. Roadmap. So what we are planning to do with APIs and Federation. So the recent feature for extensions, we added annotations, so you can mark up selected text in the Wave using extension installers. With the robot, we also now support markup operations. In the Gadget, we added the mode support and mode callback so that the gadgets can, in real time, detect the changes in the editor state. In Java and Python client library, we now support auto-generation of capabilities, which was a big problem because if people forgot to include them, the robots could break. We expanded user interface configuration in Embedding API and added more styling options. And we added configurable toolbars and footers in the embedded Wave. In Federation, we just recently opened the Federation port on the Wave sandbox. Features in development, extensions will soon have the hooks for regular expressions. It would make interaction with the robots easier. So, for example, it could be possible to detect patterns such as telephone numbers or any other textual information. So in robots, we are publishing a new version of wire protocol that makes it's more coherent than the previous version. And we are working on the gateway for open social REST access to make communication between the robots and the Wave servers secure. Gadgets. For gadgets, we are planning to add complete open social support, which would make it possible to add open social gadgets, any type of open social gadgets to the Wave, and they will behave very similarly to what they do in standard open social containers. So they will automatically match different concepts. In open social, we have friends. In the Wave, we have participants. So we will match all those concepts between the Wave and open social to make open social gadgets work correctly inside the Wave. And what's next? In extensions, we are planning to develop a dynamic extension gallery, which would make sharing extensions easier. We'd like to improve the extension installation flow to get rid of the debug menu. And in robots, we're planning to add new robot operations such as fetch wave and search wave. And robots are also in the need of performance improvements. And same applies to the gadgets. So first of all, gadgets can load much faster first time around, and there is still room for improvement in inter-client communication between the gadgets. We also would like to add diff on open support for the gadget, which means that when you left the Wave and then came back to the Wave, the gadget will be able to show what happened between the last time you saw the gadget and now. So it will show the difference. So in a game, it can show a few moves from the previous state to the current. And it can do the same with all other types of the gadgets. So for the federation, the next step is to open port on the preview wavegoogle.com. And a few future features. For extensions, we need internationalization and extension store. For robots, we need the same edit view distinction as we have with the mode in the gadgets now. We'd like to support non-app engine robots. In theory, you can run robots anywhere you want, but currently, for convenience and security reasons, you can only do this on the app engine. In gadgets, we'd like to develop UI wave library, which will help you to make gadgets wavier, meaning that if you have text within the gadget, the text will be editable with the same concurrency in the same way as in the normal wave text. Currently, it's impossible to set a cursor and type and see the updates live in other clients within the gadgets. So, and UI wave library will help with that. We'd like to explore Caja support in the gadgets. Caja can make gadgets much more secure. Currently, gadget can run absolutely any scripts from any website, and it can be abused this way. There are a few security issues that it may cause. Caja will sanitize the scripts within the gadgets and will disallow any suspicious activity. So it will be practically impossible to add gadgets with that can do any malicious activity. We're also planning to add inline gadgets. Rather than taking full width of the wave panel, they will be like elements within the text, so they will flow with other parts of the wave. In Embedding API, we are planning to add read-only and anonymous access, so which will help to embed waves into public forums and other types, and use waves for other types of applications. And we're planning to add more display configuration options as well. For the federation, we are planning to open source more client and server code, so aiming to open up as much of that as possible. And we're planning to develop a production quality reference implementation for the client and server. So thank you. And well, please try to write something interesting in the wave, and good luck. So you can ask questions now, and we'll also have office hours from 5:30 to 6:30 over there. So you can just stop by and ask me questions in person.